Hi, this is Dr. Jenny, and this is a continuation of problem 6.3. Now we're working on part C. In this part, we are to find a model for predicting the average fare on a new route. So the first step is to convert the categorical variables into dummy variables, which you've probably already done in the previous steps. But let's just go through it so that we can recall. Remember that when you partition, we want to partition the vacation slot, Southwest, and gate. So there's 4 of them that we're going to transform into categorical data. If you recall that once you do your categorical data, let me see if I can pull this over so you can see what I'm talking about, because I'm referring to my PowerPoint here a little bit as well. Let me get it here. We're basically going to clean up that data so that we're removing the no columns. Basically what I did is I tried to remove the no columns every place. So if it was, I removed the no. For slot I removed controlled, and for gate I removed constrained. You can do it the other way, but then when I start showing you how to do the predictors, yours will be a little slightly different. It doesn't mean it won't work. It'll just be it won't match up to exactly what I'm showing you. Once we've cleaned up our data, then we're going to have a sheet that looks something like this, and let me pull this over a little bit so I can show you that. I actually have here created at the data after the dummy variables were created, and then once I've done that, let me get to the answer index I've made here. Then this is the data after removing one of the columns, and this should not be new to you. This should make sense to you. So I have, notice here I have vacation yes, but you don't see vacation no. I have Southwest yes, and you don't have Southwest no, and so on. Once you have your data totally cleaned up, now you can take this data and you can partition it. You want to do a standard partition. 60/40 is fine. So let me go back to my answer index, and I will show you my training and validation set. So you can see here my training and validation, I have used the normal seed with the training rows and my validation rows, and this is a 60/40 split. So now we're ready to start our prediction. And if I go back to my answer index here for a minute, now I go here. I like hyperlinks, it works a little better. It says that we can use stepwise regression, which is multiple linear regression. Now let me just bring this over. This is an explanation out of the textbook, but stepwise selection combines forward and backward sequential approaches. The independent variable that contributes the most to explain the dependent variable is added first, and then subsequent variables are included based on the incremental contribution over the first variable and whether or not they meet the criterion for entering the equation. And I've cited my reference there. These are the steps in regression. I think this is a little bit bigger here for me to show you this, so I'll put this on here, but essentially we are using the stepwise regression. You'll see where if I go to the next one here, there's 2 steps to get the stepwise. We have to use the best subset. We want to use the 13 predictors, and then what happens is that you'll see that we have those. I'm going to show you here on my model as well. So here we'll click on this so you can see it. So here we have our subsets, and this takes a little bit because you need to notice which each of these subsets, it's adding a new coefficient or a new variable here. And so this one shows with a total of 13 variables. Well, actually it shows 14, but you notice it starts with 2. And then what you want to look here when you're looking at this is that you're looking at your adjusted R squared. And you notice here we start out with only a 0.47, and remember, the closer to 1 that we can get, the better. So the closer to 1 we can get, the better. And the least number of predictors that we can use is good. So you'll notice it's still going up, and then when you get here, you notice that now the subset is actually showing a less amount of the adjusted R squared. What this tells you is that by adding in that other variable, we're not going to get any better than that. You know, that's kind of giving you an idea. Now it also tells us in our directions that they want us to do both let me go back to the directions here. Maybe I'll get back to it. It says that basically we partition the data into training and variable, and then here's the stepwise regression, and then that's where we're looking at the models to see. So that's where we're just explaining and looking at that models. Remember, in your Jing you will need to actually do this. You will need to show that you've done this regression, stepwise regression. Next, it wants us to use the exhaustive search instead of the stepwise regression. If you look over here, what we did in the first one was we did our best subset and we did our stepwise regression. Notice that we have another choice here where we can do exhaustive search. So if I go to my exhaustive search here, it'll show that this is the model that used is the exhaustive search model that you see here. And again, we can go down here to our subsets and we'll see that we have, again, we have the 12. If I go to the 13th one, my R squared value, adjusted R squared value, does go down. So that is showing you that we get pretty much the same answer whether we do the exhaustive search or the stepwise. And you can review that in the textbook a little bit, so that you can see how, you know, how they're related, and how you arrive at that answer basic a little bit. And I'm going to go ahead and stop here because I'm already at 8 minutes, and I'll take this up in the next one.